All right, welcome back. Let's take a look at our second of four solving methods. Our second solving method is solving by finding square roots. This method is unique, and we use it mainly when we have what we call our b value equal to 0. In some quadratics, we'll have like a x squared plus 8x plus 12, where we have an a value, a b value, and a c value. So here we would say b is 8, so we couldn't use that method. But the easier way of looking at it is if there's an x squared and an x in a problem, this method doesn't work. So we can't have an x squared and an x. We have to have questions that just have an x squared. It can have other numbers, but notice that none of the other numbers are x's. So that's okay because we have x squareds and not any numbers. If we move this over to the other side, this would be our a, and then our c would be this, because our b value is always a value in front of the x. But again, the easy way to think about it is if a problem has an x squared, but no single x, then we can use this method solved by finding square roots. We're going to look at a couple examples, because there can be a couple different types. And so let's look at two. So let's start with a problem maybe like this. 3x squared minus 5 equals, I don't know, let's say 13. And so when we go to look at this, if you wanted to try to solve it the way we solved it on the other side, you would subtract 13 to get this equal to 0, but you would quickly find that maybe it's not easily factorable, or the factors don't come out really nice. And so instead, if we notice there's an x squared, but no other x value, we can just undo, and get the x squared by itself. And so when it looks like this, we're going to try to get our x by itself. To do that, we do the same kind of solving rules we always have. To get rid of a multiply by 3, we're going to divide by 3. To get rid of a minus 5, we're going to add by 5. And to get rid of the squared at the end, we're going to use the square root symbol. We just still want to make sure that we start farthest away and undo in an order that's, I guess, it makes it easiest for us. So to get rid of a minus 5, we're going to add 5. Whatever we do to one side, we do to the other. And you're going to find that this is a real familiar solving strategy because it's how we solved linear equations first semester. Now I have 3x squared, the 5's canceled out, equals 18, and so now I got to get rid of the times 3. A lot of people want a square root right here, but it's easier to get rid of the times 3 next versus having to square root the 3 itself. So let's divide by the 3 to get rid of that. The 3's cancel out to make 1x squared, or just x squared, and 18 divided by 3 is 6. Now we're really close to having this solved. We have x squared by itself. We would like x by itself. So to finish it off, we're going to square root both sides. When we square root both sides, we're going to get an answer. Now we're probably going to want to use your calculator here. Remember, the square root button is second and then the x squared button. And when you square root 6, it gives you that big long decimal. You don't need to put that entire decimal. We'll go 2 decimal places. So I'm going to look at the 4, then the 4, and then I'm going to have to decide on that second decimal place, do I keep it a 4 or round it up? And that's based on the next number over. 5 or bigger rounds up. So we're going to round this up to a 5, one bigger. So this is going to be 2.45. Now one of the things we expect at the beginning is if it's a squared equation, we expect 2 answers. And our 2 answers come into what we call the positive version and the negative version of that 2.45 decimal we got when we did the square root of 6. Remember, when we did the square root of 6, we got that 2.4, then we rounded up that 4 to get 2.45. Now the plus or minus just means I could take a positive 2.45 and times it by itself and get a 6, or I could take a negative 2.45, multiply it by itself, and still get a 6, because a negative times a negative is a positive. So when we square root it, even though our calculator only tells us the positive version, as math solvers, someone that understands what an x squared means, there's actually 2 numbers times itself that could give me 6. So we have to put the plus minus after that square root sign. And so our answers are going to be a positive 2.45 or a negative 2.45. Now just as a reminder, if we got so far, and let's say we got to the end and we did all this work and we got to the end and we got x squared equals a negative number. and you went to square root that negative number, and you went to square root it in your calculator, and I tried to square root a negative 10, don't forget that there is no number multiplied by itself that would give you a negative 10. Our calculator says domain error because there's no real number that gives you a negative 10, and we haven't gotten to imaginary numbers yet. So what we're going to just write here is if we get that domain error, we're going to just say there's no real solutions, or just no solutions to make it easier. That just means there's no number times itself that we know of yet that multiplies to negative 10. And so that's the get x by itself part. That's kind of the major part. And then the other type of problem that kind of looks like this, that kind of goes against kind of what we talked about. It doesn't go against it, but it just looks a little different, is if we had a problem that looked like this. Let's say x plus 5 squared equals 21. And we're asked to solve this. So notice this has a single x. It doesn't have just a single x squared, but there is a squared built into this equation. And so we can still do the undo, get x by itself trick, even if it looks like this. And so because of that reason, we kind of put this problem in the same category, because we are going to take the square root of both sides to solve it. So if you get any problem that looks like this, x plus 5 quantity squared equals 21, we can solve again just by trying to get rid of the two things that are bothering the x. The plus 5, we're going to subtract 5, and to get rid of the squared, we're going to square root. The difference is in this problem, the squared is the thing farther away from the x, or the least connected. So we're going to have to undo that squared before we do anything else. So we're going to square root both sides. That square rooting that squared, just like up here when we square rooted the x squared, we're just left with an x. That square root kills off that squared and just leaves me what was left in there. It just leaves me the x plus 5. And then on the other side, because I'm square rooting the 21, I know I'm going to get a plus or minus answer, because right after the square root I put plus or minus. And now I'm just going to go back to my calculator and just put in square root of 21. And when I do that, I get 4.58. I go to the second decimal, I look at the next number, it's not bigger than 5, so I can just keep it 4.58. So x plus 5 equals plus or minus 4.58. At this point, I'm still solving for x, so we want to get rid of this plus 5. So to get rid of the plus 5, we're going to subtract 5. Now what's interesting is we're actually subtracting 5 from two different numbers here. We're subtracting 5 from a positive 4.58, and we're subtracting it from a negative 4.58. So there's really two problems to do here. One is if you ignore the negative sign, then you got a positive 4.58 minus 5. So I'll type that in, positive 4.58 minus 5. And I get, oops, I typed it in wrong, 4.58. Syntax error just means you type something in wrong. Just look at what you typed. 4.58 minus 5 would give me a negative 0.42, or negative 42 hundredths. And then if I type in the other version, instead of the positive 4.58, if I type in the negative version, negative 4.58 minus 5 gives me negative 9.58, or negative 9 and 58 hundredths. And so those would become our two solutions. So instead of writing it with plus or minus, we actually end up with two completely different numbers, because the plus or minus happened the step before this. We still are kind of the same thought process. Every one of these, the thought process is the same. We want to get x by itself. We always start farthest away, and we always use inverse operations. The hard part is just recognizing them. And so if there's a single x squared and no other x's, or there's a single x and no other squareds, x squareds that is, then we can use this method. And so there'll be a sheet for you guys to practice, and you can ask questions on it. As always, if something doesn't make sense, make sure you bring it up. Make sure you get this filled in, and let me know if I can help.